Hello there, and welcome to Sleepy Galaxy Channel. It is late, or early, or one of those hours that refuses to declare itself, and you have arrived here anyway, which is the only thing tonight asks of you. There is no hurry in this room. There is no schedule waiting on the other side of these words. There is only a voice, and a long stretch of time, and a question that sounds simple until you turn it over in your hands. How long would it take to reach a meteor shower? It is the sort of question a child asks and an astronomer stumbles over, because it contains a hidden assumption, and the assumption is the loveliest part. We ask it as though a meteor shower were a destination. We picture it the way we picture a mountain range or a city on the far coast. Something fixed and findable. Something you could point a vehicle toward and eventually arrive at. But a meteor shower is not a place you go. A meteor shower is a place the Earth passes through. It is not waiting somewhere out in the dark for you to come and find it. It is a stretch of road, thinly scattered with the crumbs of an old traveler, and our whole planet drives down that road once a year at a speed no vehicle we have ever built could match, and it takes you with it whether you are watching or not. The honest answer to how long it would take you to reach a meteor shower is not measured in light years. It is measured in nights of sleep. You are already on your way. You have been on your way since the last one ended. Tonight we are going to take that answer apart slowly, and we are going to lay the pieces out where you can see them. We will spend a long while with the streams themselves, the Perseids and their enormous parent comet, the Leonids and their 33-year rhythm, the Geminids and the strange rocky object that sheds them. We will spend a long while with the size of the things that make the light, which is smaller than you expect, so much smaller that the fact rearranges something in you. We will spend a long while up at the height where the burning happens, that thin shelf of air 80 to 120 kilometers above your roof, closer than most cities you have driven to. And we will spend a long while with the people who first understood any of this, on one extraordinary night in November of 1833, when the sky over North America seemed to come apart, and a generation of frightened, sleepless watchers accidentally founded a science. If you find this useful, a like or a subscribe helps the channel reach other people also lying awake at this hour. That is all. No urgency in it. None of this needs anything from you tonight. Let your shoulders ease down away from your ears. Let your jaw unclench. Let your hands rest wherever they have fallen. Let the weight of your body be entirely the bed's problem and not yours. You do not have to remember any of this. You do not have to follow it. You are allowed to drift out and drift back and miss whole minutes, and nothing will be lost, because the thing we are describing is a thing that keeps its own appointment without any help from you. Let's begin. I want to give you an image to carry through the next couple of hours, and I want it to be an easy one that costs nothing to hold. Think of an appointment that keeps itself, not a meeting you have to remember, not something with a reminder attached, or a door you have to be at on time. Think instead of a standing arrangement made so long ago that the making of it has been forgotten, kept every year since without anyone lifting a finger, kept by the motion of the ground you are lying on. Somewhere out along the orbit of this planet there is a particular stretch of emptiness, and in that stretch of emptiness, someone left something behind. Not a person. A comet, centuries ago, or millennia, shedding dust the way a loaf sheds crumbs, laying down a long, faint trail along the path it traveled. And the Earth, going about its enormous circular business, crosses the trail, not by intention, not by navigation, simply because two paths in space happen to intersect, and both bodies keep returning to the intersection, and so the meeting happens again and again and again with a punctuality no human institution has ever managed. You do not attend that appointment. You are carried to it. That is the thread I will keep coming back to tonight, and each time I return to it, I will have something new to hang on it. The appointment that keeps itself. The meeting you cannot be late for, because you are not the one traveling. The rendezvous your planet has already booked, at roughly the same date every year, at a speed of about 30 kilometers every second, which is a number I will ask you to feel rather than calculate. So let us begin with the road itself, and with what is scattered on it. When a comet comes in from the outer dark and swings close to the sun, it warms. Not evenly, and not entirely, but enough. Comets are not solid stone. They are loose aggregates of ice and dust and frozen gases, held together loosely, closer in structure to a drift of dirty snow than to a boulder. As one approaches the inner solar system, the frozen material begins to turn directly to vapor, sublimating, skipping the liquid stage altogether in the vacuum, and as that vapor rushes off the surface, it drags loose grains of dust and rock with it. Those grains do not fall back. They do not have anywhere to fall to. The comet's gravity is far too feeble to reclaim them, so they simply keep going, drifting away from the parent body at a walking pace, a few meters per second, no faster than you might stroll across a room. But here is the part that matters. A grain that leaves the comet does not fly off in a random direction and vanish. It inherits the comet's motion almost entirely. It is moving through the solar system at nearly the comet's speed, in nearly the comet's direction, along nearly the comet's orbit. The little push it received on departure only nudges it slightly. So instead of a comet with a cloud around it, you get, over many orbits and many centuries, a comet with a road behind it and ahead of it. A vast, thin, elongated tube of debris strung out along the entire orbital path, thickest near the comet itself, thinning and spreading out with every century that passes. Astronomers call this a meteoroid stream, and the word stream is well chosen, because it behaves like a slow river of particles pouring endlessly around the same enormous loop. Now hold two things at once. Hold the road, that faint tube of scattered grains looping out beyond Neptune's distance and back and past the sun, and hold the Earth on its own far smaller loop, nearly circular, taking 1 year to come around. Where those two loops cross, you get a date, not a place you visit, a date you arrive at. Think about how strange and how ordinary that is. Every other appointment in your life is something you have to travel to. You get up, you gather your things, you cross some amount of ground, and the crossing is the effort. Here, the crossing is done for you. The ground itself is the vehicle. The Earth carries you around a loop nearly 940 million kilometers long, and it does the whole circuit in 1 year, which works out to somewhere near 30 kilometers in every second that passes. Not 30 kilometers an hour. 30 kilometers between one heartbeat and the next. In the time it takes you to notice that your breathing has slowed, the planet under you has moved further than most people travel in a week. You are not aware of it, and that unawareness is not a failure of your senses. It is a consequence of how motion works. You feel acceleration, not velocity. You feel the change, not the traveling. A train at full speed on smooth rails becomes almost indistinguishable from a room, and the Earth is smoother than any rail ever laid, turning through a vacuum with nothing to jostle it and nothing to push against. So you lie here, motionless as far as your body is concerned, being carried at 30 kilometers a second toward a stretch of debris that a comet left behind long before anyone alive had a name. And this is where the date comes in. Because the Earth returns to the same points on its orbit at the same times each year, and because the debris stream sits in a fixed place relative to that orbit, the crossing happens on a schedule. Mid-August for one of them, mid-November for another, mid-December, mid-April, early May, late July. The dates drift by a day or two over long spans, nudged by the slow shifting of orbits, but they are the most reliable appointments in the sky, more reliable than tides in a harbor, more reliable than any migration. Astronomers can tell you the peak hour of a shower years in advance, not because they are predicting an event, but because they are reading a calendar that was written by orbital mechanics and needs no updating. A meteor shower, then, is a date on the road, and this is the answer to our question, arriving much earlier than you expected, though we will spend the next 2 hours turning it around in the light. How long would it take you to reach a meteor shower? If you mean travel, the answer is that you are already traveling and have been every second of your life, and the arrival will happen whether you set an alarm for it or not. If you mean waiting, the answer is at most a few weeks, because the year is crowded with these crossings and you are never far from one. If you mean, as the question secretly means, how far away is the wonder, the answer is about 100 kilometers straight up, which is closer than the nearest large city to most of the people listening to this. That last part deserves a moment, because it undoes something. We are used to thinking of astronomy as the science of the impossibly far. The nearest star beyond our own is 4 light years off, which is to say that light, the fastest thing there is, takes 4 years to make the trip. And our fastest spacecraft would take 70,000. The galaxy is 100,000 light years across. Those numbers are so large that they stop meaning anything, and there is a kind of tiredness that comes from being told over and over how small you are against them. But a meteor is not far. A meteor is intimate. The light you see when a meteor crosses the sky is made in a layer of atmosphere that a commercial aircraft could not reach, but a good rocket could pass through in about 90 seconds. It happens above the weather, above the clouds, above the highest storms, but well below anything you would call outer space in the sense of orbits and satellites. If you could drive straight up at motorway speed, you would arrive at the meteor layer in about an hour. It is the nearest astronomy there is. It is the one branch of the sky that comes down to meet you. So we are dealing with 2 distances at once, and I want you to hold both of them without letting either one press on you. The first distance is the enormous one, the orbit of the parent comet, sweeping out past the giant planets, taking decades or centuries to complete a single circuit, laying down its trail across a volume of space so large that our whole planet is a speck crossing it. That is the distance of the road. The second distance is the tiny one, 100 kilometers, straight up, an hour by car if cars could climb. That is the distance to the light. The stream is vast, and the encounter is near. Both are true, and neither cancels the other, and there is something restful in a fact that refuses to be only one size. Let me stay with the road a little longer, because the shape of it explains almost everything else we are going to talk about. Picture the orbit of a comet as an ellipse, but a badly stretched one. Nothing like the near circle the Earth travels. At one end of the ellipse, the comet swings in close to the Sun, moving at its fastest, sometimes covering tens of kilometers a second. At the other end, it is out in the cold, far past the orbit of Neptune in some cases, crawling along at a fraction of that pace, taking years to cover a distance it would cross in days near the Sun. This is not a quirk of comets. It is simply what gravity does to anything on an eccentric path, fast where it is close, unhurried where it is far, and the trade is exact, worked out by Kepler 4 centuries ago, and never once broken since. Now, scatter the dust. Each grain that leaves the comet is released at a slightly different moment, in a slightly different direction, with a slightly different push. A grain nudged forward gets a marginally larger orbit, and therefore a marginally longer year. A grain nudged backward gets a smaller orbit and comes around a little sooner. Over 1 revolution, the difference is negligible. Over 10, it grows. Over 100, the grains that left together have smeared themselves all the way around the loop, the early ones lapping the late ones, until what began as a puff near the comet becomes a continuous ring of particles following the entire orbital path. One enormous thin tube of debris, with the comet somewhere inside it, no longer the owner of the trail so much as one more traveler on it. That smearing is why a shower can happen even when the parent comet is nowhere near. The perseids arrive every August with complete dependability, though their parent comet last came through the inner solar system in 1992 and will not return until 2126. It does not need to be here. It left the road behind. The road is the thing we cross. And the road is old. Some of the dust the Earth sweeps up in August was shed centuries ago and has been quietly orbiting ever since, going out to the far cold and coming back in over and over, waiting without any capacity for waiting, unaware of the appointment it is keeping. That is the second turn of our thread. An appointment kept by 2 parties, neither of whom knows they made it. Now let me tell you about the point in the sky that everything seems to come from, because it is one of the loveliest illusions in astronomy, and because understanding it will change what you see the next time you are outdoors after midnight. If you watch a meteor shower for long enough, an hour, perhaps 2, lying on your back with your eyes unfocused and the whole dome of the sky in view, you begin to notice a pattern that you did not notice at first. The streaks do not run in random directions. Trace each one backward, extend the line it drew before it appeared, and the lines converge. They meet at a single small region of sky, and they meet there with an accuracy that feels almost designed. The meteors near that region are short, barely more than a flash. The meteors far from it are long, drawn out, arcing halfway across the heavens, and all of them, short and long alike, point back to the same spot. That spot is called the radiant, and the shower is named for whatever constellation it happens to fall in. Perseids radiate from Perseus, Leonids from Leo, Geminids from Gemini, Lyrids from Lyra. The constellation has nothing whatever to do with the debris. It is simply the backdrop, hundreds of light years behind, a set of unrelated stars that happen to lie in the direction we are looking. Naming the shower after them is like naming a rainstorm after the mountain you happen to see through it. Here is what is actually happening. Every particle in the stream is traveling along essentially the same path in the same direction, because they all inherited that path from the same parent. When the Earth plows into the stream, we meet all of them coming from the same direction, moving in parallel. Parallel lines seen from within, in perspective, appear to converge on a vanishing point. That is the whole of it. That is the entire mechanism. The radiant is a vanishing point in the sky. You already know this effect intimately, though you have never called it that. Think of driving at night through falling snow. The flakes are drifting more or less straight down, or slanting with the wind, but from behind the windscreen they seem to stream outward from a point in the middle of the glass, rushing past the sides of the car, spreading as they come. Nothing is emanating from that point. It is simply the direction you are moving. Or think of standing on a long straight road and looking down it. The two edges of the tarmac are parallel, exactly and provably parallel, and yet they meet at the horizon, and no amount of knowing that they do not meet will make your eyes stop seeing it. The radiant of a meteor shower is that same convergence, painted on the ceiling instead of the ground, which means the radiant tells you something intimate about your own motion. It is not a place, it is a direction. It marks, quite precisely, the direction from which the debris is arriving relative to you, which is another way of saying it marks the direction the Earth is heading, combined with the direction the stream is flowing. When you look at the radiant, you are not looking at a source. You are looking at the point your planet is aiming toward through that particular river of dust. You are, in the most literal sense available, watching where you are going. There is a small further consequence of this, and it is the reason so many showers are better after midnight and better again in the hours before dawn. It has to do with which side of the Earth you are standing on. The Earth turns as it orbits. That means that at any moment, half the planet is on the leading side, the side facing the direction of travel, and half is on the trailing side, facing back the way we came. Around midnight and through the small hours, your part of the world has rotated onto the leading face. You are on the windscreen. Around evening, just after sunset, you are on the rear window instead, and only the fastest particles, the ones catching up from behind, can reach you at all. This is why almost every experienced observer will tell you the same unglamorous thing. The best hours are the ones nobody wants. 2 in the morning. 3, 4, the hours when the world has emptied out and the traffic has stopped and there is nobody to share the sky with. The rates climb toward dawn not because the shower has intensified, but because you have rotated into the windscreen position, sweeping directly into the oncoming stream. If you are lying awake now at one of those hours, I want you to notice something. You are already in the position the sky rewards. Whatever kept you up, whatever will not let your mind settle, has placed you on the leading face of a planet moving toward a stretch of ancient dust. That is not a consolation, exactly. But it is a fact, and there is something in it that takes the edge off the loneliness of being awake when others are not. There is one more thing worth knowing about the radiant, and it is a detail that pleases people who like their explanations to lock together. The radiant is not perfectly a point. It is a small area, typically a couple of degrees across, roughly 4 times the width of the full moon. And it is not a point because the stream is not perfectly uniform. The particles have slightly different orbits, slightly different speeds, slightly different arrival angles, accumulated over centuries of drifting. The spread of the radiant is therefore a direct readout of the age and scatter of the stream. A young, compact stream, freshly laid down, gives a tight radiant. An old, well-mixed stream gives a fuzzier one. Astronomers can look at the fuzziness and infer how long the dust has been out there, the way you might guess the age of a footpath from how far its edges have blurred into the grass. The radiant also drifts, night by night, across the background stars. Not because the stream moves, but because the Earth's own direction of travel changes continuously as we curve around our orbit, Over the 2 or 3 weeks a shower is active, its radiance slides steadily eastward, a degree or so per night, and the amount of that slide is another fingerprint, another way of reading the geometry of the encounter from the ground. All of which is to say that the sky, on a night when a shower is running, is quietly full of information. Every streak carries a record of where it came from and how fast it was going and how long its parent has been shedding. Nobody has to decode any of it for the sight to work on you. The light is beautiful whether or not you know the geometry. But the geometry is there, folded into the light, available to anyone patient enough to lie on their back for an hour and let their eyes learn the pattern. And the appointment goes on keeping itself, whether it is decoded or not, whether it is watched or not, whether the sky above your particular roof is clear tonight or thick with cloud. That is the part I keep returning to. The reliability of it has nothing to do with attention. The stream does not need an audience. The earth does not check whether anyone is looking before it crosses. Let us talk now about speed, because speed is where the light comes from, and because the numbers involved are among the few numbers in astronomy that can be felt rather than merely acknowledged. We have said the Earth moves at about 30 kilometers a second. Hold that. Now consider a particle in a meteoroid stream, which is also orbiting the Sun, also obeying the same gravitational rules, also moving at tens of kilometers a second. When the two meet, what matters is not either speed on its own, but the difference between them, the relative velocity, the closing speed of the encounter. And that depends entirely on the angle. If the stream is traveling in roughly the same direction as the Earth, in the same sense around the Sun, then we are overtaking it, or it is overtaking us. And the closing speed is the small difference between two large numbers. Those are the leisurely meteors. They come in at around 11 or 12 kilometers a second, which is as slow as a meteor can possibly be, because 11 kilometers a second is the speed anything falls at when it arrives at Earth from far away, with no velocity of its own. You cannot arrive more slowly than that. Gravity will not permit it. Even a pebble drifting motionless in the Earth's path will be accelerated to 11 kilometers a second by the time it reaches the upper air, simply from falling down the well. If instead the stream is traveling against us, orbiting the Sun in the opposite sense, then we meet head-on, and the speeds add. 30 from us, 40 from them. And the closing speed climbs towards 70 kilometers a second, which is the practical upper limit for anything bound to our Sun. Those are the fastest meteors in the sky. The Leonids are the classic case. Their parent stream runs retrograde, backwards around the Sun compared to the planets, so every November the Earth meets Leonid particles almost precisely head-on, at about 71 kilometers a second. That is roughly 250,000 kilometers an hour. That is a quarter of the way to the Moon in 1 hour. That is fast enough that a Leonid crosses the entire luminous portion of its flight, tens of kilometers of it, in well under a second, which is why Leonids look like scratches on glass rather than falling objects, and why so many of them leave a persistent train, a faint glowing line that hangs in the air for seconds afterward, drifting and curling with the winds of the upper atmosphere. The perseids sit in between, arriving at around 59 kilometers a second, angled but not opposed. The Geminids are on the unhurried end, coming in around 35, which is part of why Geminid meteors look different. They burn longer, hold their light steadier, and often show color, yellows and greens and the occasional orange, where a Leonid is a white flick and gone. Now, why does speed make light at all? There is a phrase you may have heard, that meteors burn up from friction with the atmosphere, and it is the sort of explanation that is close enough to be useful and wrong enough to be worth correcting. because the true mechanism is better. At 70 kilometers a second, a grain of dust is not rubbing against the air. It is far too fast for anything so mild. It is arriving so quickly that the air molecules in front of it cannot get out of the way. They are struck and compressed and driven ahead in a shock front, and the compression heats that thin sliver of gas to thousands of degrees, hotter than the surface of many stars, in a layer only millimeters thick. The heat does not come from rubbing. It comes from the violent squeezing of air that had no time to move aside, and then the grain itself begins to come apart, not by burning in the chemical sense, not by combustion, but by ablation. The surface atoms are heated until they leave the solid entirely, boiling and stripping away into the surrounding gas. Those liberated atoms, iron and magnesium and sodium and calcium, are slammed into the air molecules around them at enormous speed, and the collisions knock electrons into higher energy states. When the electrons drop back down, they release photons, they release light. So the streak you see is not the grain, and it is not a flame. It is a column of excited air and vaporized metal. A tube of glowing gas perhaps a meter across and many kilometers long, lit up for a fraction of a second by atoms falling back to rest. The colors, when you see them, are the elements announcing themselves. Sodium gives a warm orange-yellow. Magnesium gives blue-white. Iron gives a yellowish tone. The oxygen and nitrogen of our own atmosphere, excited by the passage, give the greens that so many people notice and so few expect. Every meteor is a small, unrepeatable spectroscopy experiment, a chemical analysis performed by collision and readout in color, and the reading takes less than a second and is never repeated with the same sample twice. This is why the fast showers look sharp and the slow ones look rich. Energy rises with the square of the speed, so a Leonid at 71 kilometers a second carries roughly 4 times the energy per gram of a Geminid at 35. It deposits that energy higher in the atmosphere, faster, in a shorter burst, and it is finished before your eye has properly registered it. The Geminid, arriving at half the speed, penetrates deeper before it is consumed, glows for longer, and gives you time to actually watch it happen. I find something restful in that distinction. The fastest things are the ones that leave the least impression. The unhurried ones are the ones you get to see. Let me put the speed into a form that has some texture to it, because 70 kilometers a second is an abstraction, and I would rather give you an image. In the time it takes to say the word meteor, a Leonid particle travels the length of a marathon course. In the time it takes you to inhale, it could cross the English Channel about 20 times. If it could somehow keep that speed at ground level, it would go from London to New York in about 80 seconds, and from one side of the continental United States to the other in roughly a minute. It is moving fast enough that the entire depth of the meaningful atmosphere, the whole shelf where meteors live, is crossed in less time than it takes a dropped coin to hit the floor. And it stops. That is the part that gets overlooked. It stops completely. A grain that has been traveling at 70 kilometers a second, unimpeded, for centuries, is brought entirely to rest by less than 100 kilometers of extremely thin gas. What began as a fragment of a comet in the outer solar system ends as a scattering of individual atoms suspended in the upper air of a planet, and those atoms then take weeks or months to drift down, settling eventually into rain, into oceans, into soil, into the ordinary dust that gathers on the top of a bookshelf. Somewhere between 40 and 100 tons of this material arrives every day. Not on shower nights, especially. Every day. The sky is always delivering. and almost all of it arrives too small and too faint for anyone to notice, which means the appointment is not really annual at all. The annual crossings are simply the ones large enough to see. Which brings me to the fact that rearranges people, the one I mentioned at the start, and I want to arrive at it without ceremony, because it does its work best when it is simply set down in front of you. The thing that makes a bright meteor is about the size of a grain of sand. Not a pebble, not a stone, not a fist-sized rock glowing as it falls. A typical meteor, one bright enough to make you sit up and point, is produced by a particle somewhere between a millimeter and a centimeter across, weighing a fraction of a gram. Many of the fainter ones are smaller than the full stop at the end of a printed sentence, something you could hold 100 of in one palm without feeling the weight, something that would vanish in the crease of your hand. And that speck, arriving at 50 or 60 kilometers a second, produces a flash of light visible across 100 kilometers of countryside, seen simultaneously by people in 3 different counties who will each believe it passed directly over their own house. Sit with that for a moment. The largeness of the effect and the smallness of the cause. There is a whole philosophy buried in it, and I am not going to dig it out and hand it to you, because it works better if you find it yourself somewhere around 3 in the morning. The reason a grain of sand can do this is entirely the speed. Energy of motion rises with the square of velocity, and 60 kilometers a second is an extraordinary velocity. So 1/10 of a gram arriving that fast carries roughly the energy of a kilogram of high explosive. All of that energy is dumped into a narrow column of extremely thin air in less than a second. There is nothing to absorb it and nothing to muffle it. It comes out as light and as heat and as a faint radio-reflective trail of ionized gas that radio astronomers can bounce signals off in broad daylight, detecting showers that no eye could ever see because the sun is up and the sky is blue. The occasional larger arrivals get their own word. A meteor brighter than the planet Venus is called a fireball, and a fireball is usually produced by something the size of a marble or a walnut. Brighter still. Bright enough to cast shadows on the ground and make people look up from their driving, and you may be dealing with an object the size of a fist. Those are rare, a handful per shower, if the shower is generous. And they sometimes end with a soft rumble or a distant boom arriving a minute or two later, the sound taking its slow time behind the light. But almost none of it reaches the ground. Almost none of it survives. Shower meteors in particular, being cometary dust, loose and porous and structurally weak, are completely consumed high up. They are not rocks. Held in your hand, a piece of comet dust would be less like gravel and more like a fragment of burnt paper, a fluffy aggregate of grains held together by nearly nothing, so fragile that it comes apart on contact with air 100 kilometers thick and thinner than the best vacuum most laboratories can produce. This is worth saying plainly, because the question sits under the surface for a lot of people watching. Meteor showers do not put anything through your roof. The material is too small, too weak, and too high. The stones that do occasionally reach the ground come from a different population entirely, fragments of asteroids, dense and strong, arriving on unrelated paths, and they arrive at random and have nothing to do with the annual streams. On a shower night, the sky is at its most spectacular and its most harmless at the same time. It is a display made of dust, staged 100 kilometers up, and every part of it is over before it could ever come near you. So let us go up to where it happens, because I promised you that layer, and it deserves a proper visit. Above your ceiling there is the ordinary air you breathe, dense and busy, holding weather and birds and the noise of the world. 10 kilometers up, you pass the top of that layer. Above the clouds, above the storms, above the cruising altitude of aircraft, into a region where the air is cold and dry and remarkably steady. 20 kilometers, 30, and you are in the ozone region, where a thin smear of a particular molecule absorbs the ultraviolet that would otherwise sterilize the surface. 50 kilometers, and the pressure has dropped to 1,000th of what it is in your room. Somewhere around 50 kilometers, the temperature begins to fall again, and you enter the mesosphere. And this is the part of our atmosphere that hardly anyone thinks about, because it is the hardest region to reach. It is too high for balloons, which run out of air to float in. It is too low for satellites, which would be dragged down within days. It has been called, half seriously, the ignorosphere, for the simple reason that it is a place we have almost never been able to linger, and it is exactly where meteors live. The luminous flight of a shower meteor begins around 120 kilometers up, sometimes a little higher for the fastest ones, and ends around 80 kilometers, sometimes lower for the slower and sturdier ones. That band, 80 to 120 kilometers, is the meteor layer. It is the stage. Every streak you have ever seen was performed inside that shelf, and the shelf is roughly 40 kilometers deep, which is nothing at all on the scale of a planet, a film of gas thinner in proportion than the skin on an apple. The air up there is almost not air. The pressure is around 1/1,000,000th of what you are breathing. If you took a cubic meter of it and compressed it down to sea level density, you would have a volume smaller than a sugar cube. It is so thin that the concept of temperature starts to get slippery, and yet it is dense enough, just, to stop something moving at 70 kilometers a second. That is the improbable balance of it. Nearly nothing, and yet sufficient. I want you to appreciate the closeness once more. 100 kilometers. If you have ever driven for an hour on an open road, you have covered the distance to the meteor layer. If you live in a large country, you have neighbors further away than that. Horizontally, the nearest airport, the nearest coast, the nearest city with a different name than yours, may well be further off than the place where a comet's dust turns into light. And what happens up there is a kind of arrival. That thin band is where the solar system stops being somewhere else and becomes part of the Earth. A grain that has been orbiting the sun for 1,000 years, out past Neptune and back, alone in the cold the entire time, meets its first resistance in that layer, and in less than a second it stops being an object and becomes a scattering of atoms in our air, and then it is ours. It is not visiting. It has joined. Every one of us is breathing air that contains, in small measure, the disassembled remains of comets. It has been happening the whole time you have been listening. Now let me take you back, because none of this was known until surprisingly recently, and the night it began to be known was one of the strangest nights in the recorded history of the sky. For most of human history, meteors were weather. That is not a joke or a simplification. It was the settled scientific position, inherited from Aristotle and held for 2,000 years, that shooting stars were atmospheric phenomena, exhalations of the upper air, kin to lightning and rainbows and the aurora. The word meteor itself comes from a Greek root meaning raised up, high in the air, and it is the same root that gives us meteorology. For 20 centuries, the study of shooting stars and the study of rain belonged to the same discipline, and there was no particular reason to think otherwise. Things fell, sometimes. The sky did things. Nobody had a way to measure how high they were. Even by the late 1700s, the idea that stones could fall from beyond the earth was regarded by serious people as a peasant superstition. There is a story, probably improved in the retelling, of a French academy dismissing eyewitness accounts of a stone fall, with the observation that stones do not fall from the sky because there are no stones in the sky. Museums are said to have discarded meteorite specimens to avoid the embarrassment of holding folklore in their collections. The skepticism was not stupidity. It was the reasonable position given what could be measured, and what could be measured was almost nothing. The first crack in it came from two young men in Germany in 1798, students named Brandes and Benzenberg, who did something so simple that its brilliance is easy to miss. They stationed themselves about 15 kilometers apart, agreed on a timing method, and each recorded exactly where in the sky they saw each meteor. When they compared notes, the same meteor had appeared against slightly different backgrounds from the two locations. That difference is parallax, the same effect you get by holding a finger up and closing one eye and then the other, and parallax gives you distance. Their numbers were rough, but the conclusion was not. The meteors were far above the atmosphere in any ordinary sense. They were high, higher than any cloud, higher than any weather. They were, as we would now put it, at the top of the air, at the boundary where the Earth ends. That result sat there for 35 years, interesting and unpursued, because there was no framework to put it into. And then came the night of the 12th to the 13th of November, 1833. The people of Eastern North America woke that night to a sky that had, to every appearance, come apart. Accounts agree remarkably well, which is unusual for accounts of anything. Meteors fell in numbers nobody had language for. Estimates run to tens of thousands per hour, and in places over 100,000, which is to say 20 or 30 every second, a continuous rain of light from horizon to horizon lasting hours. It was bright enough to wake sleeping people through curtained windows. It was bright enough to read by. Farmers rose thinking their barns were on fire. Church bells were rung. Whole towns came out into the roads in nightclothes. For very many of those watchers, and this is where the human part of the story lives, it was understood as the end of the world. The imagery was already available to them from Scripture, stars falling to earth as a fig tree casts its fruit, and here it was in the sky above Virginia and Massachusetts and Tennessee. There are recorded accounts from enslaved communities in the American South, for whom the night became a permanent landmark in memory, referred to for decades afterward as the night the stars fell, used as a fixed point to date births and marriages and events in lives that the official records did not bother to date. The phrase survived long enough to become the title of a song. Whole biographies were anchored to it. It was, by any measure, a night of great fear, and out of that fear, within days, came the beginning of a science. Because a number of people, in the middle of it, kept their heads and took notes, and two observations, made independently by several of them, turned out to be the keys to everything. The first was that the meteors all appeared to come from a single point in the constellation Leo. The second, subtler and more decisive, was that this point moved with the stars. It rose with Leo, tracked across the sky with Leo, and stayed fixed against the constellation all night long, rather than staying fixed relative to the ground. That second observation is a nail through the old theory. If the meteors were an atmospheric event, a disturbance in the air above a particular region, the radiant would have stayed put over the landscape. It did not. It traveled with the stars, which meant the source direction was external to the Earth entirely, out in space, unaffected by the planet's rotation beneath it. The falling stars were not weather. They were something we were running into. A Yale professor named Denison Olmsted published on it within weeks, gathering accounts by letter from across the country, working out the radiant, and proposing that the Earth had passed through a cloud of particles orbiting the Sun. He got some of the details wrong, as one does when inventing a field. He got the essential shape of it right. Then the historians went to work, and the historians turned out to matter as much as the observers. Someone thought to look for earlier reports, and the records began coming in. A great meteor display in November 1832, seen from Europe and the Middle East. Another in November 1799, described in South America by Alexander von Humboldt, who wrote of the sky being full of them for hours, and then, going back through Arab and Chinese and European chronicles, more of them, scattered across 1,000 years, clustering in November, clustering around a rhythm of roughly 33 years. 33 years. That was the number that unlocked it. It was not just an annual event that could occasionally be spectacular. There was a longer cycle underneath, a period, and a period means an orbit. A prediction was made for 1866, which was 33 years on from 1833. And in November 1866, the sky over Europe filled with meteors on schedule. That is the moment, more than any other, when meteors became a science. Not the observation, not the theory, but the prediction that came true. From that point on, the streams were understood as orbiting bodies of debris, and orbits could be computed, and computation meant everything. Within a couple of years, the connection was closed. Giovanni Schiaparelli, in Italy, calculated the orbit of the Perseid stream from careful timing and radiant work, and then compared it with the recently determined orbit of a comet that had appeared in 1862, Comet Swift-Tuttle. The two orbits matched, not approximately. They matched in a way that could not be coincidence. The August meteors were following the exact path of a known comet. The same reasoning was applied to the Leonids, and their orbit matched Comet Tempel-Tuttle, discovered in 1865 and 1866, with a period of 33 years. There it was. The 33-year rhythm in the old chronicles was the comet coming back around and refreshing the dust it left along its path. In the space of about 3 decades, meteors went from being a form of weather to being the visible remains of comets, on known orbits, arriving on predictable dates, and the whole thing was set in motion by a night when a very large number of frightened people looked up, thought the world was ending, and had the presence of mind to write down what they saw. There is something in that I find worth carrying. The instinct that made 1833 terrifying and the instinct that made it scientific were the same instinct: to look up, to pay attention, to try to make sense of it. Fear and curiosity came out of the same root that night, and only one of them lasted. Let me introduce you properly to the streams themselves now, one at a time, unhurried. Because each one has a character, and a history, and a parent. And because there is a pleasure in knowing which appointment you are keeping when you keep it. We begin with the Perseids, in August, which are the ones most people in the northern half of the world have actually seen, largely because they arrive during the only month when lying on damp grass at 2 a.m. is a reasonable thing to do. The Perseids are the dust of Comet Swift-Tuttle. And Swift-Tuttle is an object worth pausing on, because it is not a small one. Its nucleus is around 26 kilometers across, which makes it one of the largest objects known to make repeated close approaches to the Earth's orbit. Comet Halley, for comparison, is about 11 kilometers on its long axis, Swift-Tuttle is the biggest regular visitor we have. It takes about 133 years to go around. Out at the far end of its orbit, it is beyond Pluto's average distance, moving through a cold and enormous dark, taking decades to cover ground it will later cross in weeks. Then it comes back in, warms, sheds, and swings around the sun before heading out again. It was seen in 1862 by two American astronomers within days of each other, hence the double name. It was seen again in 1992, which was its first return since the discovery. It will come back in 2126, and there are people alive tonight, small ones, who may well see it. But the perseids do not care whether the comet is here. The road is laid, and the Earth crosses it every year in the second week of August, meeting the dust at about 59 kilometers a second, at an angle steep enough to make the meteors fast and bright, but not so head-on as to make them merely flicks of white. Perseids are generous meteors. They are frequently bright. They often leave short trains, and the shower produces a reliable number of fireballs, more than most, probably because Swift-Tuttle is so large and has been shedding correspondingly substantial grains for a very long time. A good Perseid night, from somewhere properly dark with the radiant high and the moon out of the way, will give you somewhere near 100 meteors an hour at the peak. That figure comes with caveats we will get to. But it is enough that you never wait long. Enough that, lying back for an hour, you would see one every minute or so, arriving unannounced from the northeast, drawing its line and vanishing. The perseids have been recorded for a very long time. Chinese chronicles note meteors in that August window as far back as the year 36 of the Common Era, which is nearly 2,000 years of the same appointment being kept. In parts of medieval Europe, the shower fell close enough to a saint's feast day in early August that the meteors acquired a nickname, remembered as the tears of that saint, falling every year in the same week. An explanation that is entirely wrong and rather beautiful, and which at least had the merit of noticing the regularity. 2,000 years of records. The same date. The same direction. Empires have come and gone inside the span of that reliability, and the stream has not noticed any of it. Now, the Leonids, in November, which are the drama. Their parent is Comet Tempel-Tuttle, a far smaller object than Swift-Tuttle, only a few kilometers across, on a tight 33-year orbit that keeps it much closer to home. Because the Leonid stream is retrograde, running against the direction of the planets, we meet it head-on at about 71 kilometers a second, the fastest regular meteors we get. In an ordinary year, the Leonids are modest. 10 or 15 an hour, perhaps 20. Pleasant, unremarkable, easy to miss if the weather is uncooperative. Most years, that is the whole of it, but every 33 years or so, when Tempel-Tuttle has recently swung through and left a fresh, dense ribbon of dust near its orbit, and when the Earth happens to pass close enough to that fresh ribbon, the Leonids do something else entirely. They storm. The word storm has a technical meaning here. A meteor storm is conventionally defined as a rate above 1,000 per hour, which is more than 15 a minute. The 1833 display, the one that founded the science, is estimated to have reached somewhere between 50 and 150,000 per hour at its height. That is a rate at which the individual meteors stop being individual. Observers described the sky as being full, as being in motion, as resembling snow driven past a lamp. It happened again in 1866, as predicted. It was expected in 1899 and failed, largely because Jupiter and Saturn had nudged the stream slightly aside, and the failure was a public embarrassment that set the field back for a generation. It came back in 1966 over the American Southwest, and for about 15 minutes on the morning of the 17th of November, the rate is estimated to have exceeded 100,000 an hour, one of the most intense displays ever properly witnessed by trained observers. And then, in 1999 and 2001 and 2002, it happened again. And this time, something new was possible. By then, the modeling had matured. Astronomers had learned to treat the stream not as one uniform tube, but as a bundle of separate ribbons, each laid down on a specific past passage of the comet, each drifting according to its own history, each perturbed by the giant planets in a computable way. They could say, on this date, at this hour, the Earth will pass through the ribbon shed in 1767, and then through the ribbon shed in 1866, and the rates will be roughly this. And they were right. Not roughly right, right to within minutes, and within a reasonable factor on the rates. In November 2001, observers across the Pacific and North America saw storm-level activity beginning and ending almost exactly when the models said it would. I want to underline what that means, because it is one of the quiet triumphs of celestial mechanics, and it hardly ever gets celebrated. We are now able to predict, years in advance and to the hour, when our planet will pass through a particular thread of dust released by a particular comet on a particular passage more than 2 centuries ago. We can track individual exhalations of an object that has been breathing out dust since before anyone was measuring, and know where each breath has drifted to. The next likely Leonid activity of any real intensity is expected in the 2030s, when Temple Tuttle comes around again. It may storm, it may not. The ribbons have to be in the right places, and the Earth has to thread them, but the appointment will be kept regardless, at the ordinary level, in the middle of November, whether anyone is out to see it or not. And this is the shape of the thread again, one more turn of it. Some appointments are quiet, and some are overwhelming, and the difference has nothing to do with whether the appointment was kept. It was always kept. Only the density of the road changed. Then there are the Geminids, in December, and the Geminids are the puzzle. For most of the 20th century, they were an anomaly with no explanation. They were reliable, they were rich, they had been steadily strengthening decade by decade since they were first properly noticed in the 1860s, and they had no parent comet. Astronomers looked. They computed the orbit of the stream, which is an unusual one, tight and small, bringing the particles closer to the Sun than Mercury ever goes, and they searched for a comet on that path, and there was nothing there. In 1983, an infrared survey satellite found the answer, and the answer was not a comet. It was an asteroid, a dark rocky object about 5 kilometers across, given the name Phaethon, after the figure in Greek myth who drove the sun's chariot too close and was destroyed for it. The name is unusually apt. Phaethon's orbit takes it to within about 21 million kilometers of the sun, less than half of Mercury's distance, where its surface is heated to somewhere around 700 degrees. An object like that has no ice left to speak of. It cannot shed dust the way a comet does, by sublimation. And yet the Geminid stream is one of the densest we cross, carrying more material than the Perseids by a considerable margin. The current explanation is thermal. Rock heated to 700 degrees and then carried out into the cold, over and over, on a cycle of about 1.5 years, will crack, it will fracture, it will flake, it will shed. There may also be sodium boiling out of the surface, driving small ejections. Phaethon has been observed brightening near its closest approach and trailing a short dusty tail, which earned it the working nickname of a rock comet. an object that behaves like a comet through an entirely different mechanism. So the December meteors are made of stone rather than snow. They are denser, tougher, better able to survive a little longer in the air, which is why they come in more leisurely and glow with more color and last long enough to actually follow with your eye. They are also the only major shower whose radiant is high in the evening, which means you do not have to wait until the small hours to see them well, which is a kindness in December. And there is something quietly poignant in the Geminids if you want it. The stream is young, only 1,000 or 2,000 years old by most estimates, which makes it an infant compared to the Perseids. It is still tightening, still intensifying, still being laid down. It was not there for most of human history, and it will not be there forever. Some models suggest it will dissipate within a few thousand years. We happen to be alive during the part of its life when it is at its best. Beyond the 3 great ones there is a whole calendar of others, and I will lay them out for you now, not because you need to memorize anything, but because a list, read at an unhurried pace, is a restful thing to listen to. In early January, there are the quadrantids, which are sharp and brief, peaking within a window of only a few hours, named for a constellation that no longer officially exists, having been abolished by a committee in the 1920s while the meteors carried on regardless. In late April, there are the Leonids, which are among the oldest recorded of all, noted in Chinese records around 2,500 years ago, occasionally throwing an unexpected surge. In early May, there are the Eta Aquarids, which are the dust of Halley's comet, arriving on one side of its orbit, best seen from the southern hemisphere, fast and fine. In late October, there are the Orionids, which are the dust of the same Halley's comet arriving on the other side, the same road crossed at a second intersection, twice a year, from a comet that will not itself return until 2061. Through late July and into August, there are the Delta Aquarids, an unhurried, diffuse shower with a poorly understood parent overlapping with the beginning of the perseids, so that anyone watching in early August is really watching 2 streams at once. Through October and November, there are the Taurids, which are slow and sparse but produce a disproportionate number of fireballs, drifting in from a wide, dispersed old stream associated with Comet Encke, which some researchers think is one fragment of a much larger object that came apart thousands of years ago. And in December, after the Geminids have finished, there are the Perseids, faint and cold and largely unwatched, arriving in the week before the solstice when almost nobody is looking up. That is not the complete list. There are dozens of minor showers, over 100 established ones and hundreds more provisional, most producing only a meteor or 2 an hour, detectable mainly by cameras and radar. The Earth is not crossing a few isolated roads, it is crossing a network, a whole tangled arrangement of old trails laid down by objects that came and went and in many cases no longer exist at all. There are streams out there whose parent comets have entirely disintegrated. The dust outlives the body that made it. The road remains after the traveler has gone, and the Earth keeps meeting the road, and the appointment keeps being kept with a party that is no longer present to keep it. I will let that sit rather than press on it. The dates, then, if you want them as a rhythm to fall asleep to. Early January, the Quadrantids. Late April, the Leonids. Early May, the Eta Aquarids. Late July, the Delta Aquarids. Mid-August, the Perseids. Late October, the Orionids. Through November, the Taurids and then the Leonids. Mid-December, the Geminids and then the Perseids, just before the year turns. 9 or 10 appointments a year, spread across the calendar so that you are never more than about 6 weeks from one. Whatever month it is as you listen to this, there is a crossing behind you and a crossing ahead of you, and the gap between them is smaller than you would have guessed. This is what I meant right at the beginning when I said the answer is measured in nights of sleep, not in distance, not in fuel, in how many times you will close your eyes between now and the next intersection. Perhaps 40, perhaps 10. Perhaps, if the date happens to be right, you are on your way to one tonight, and the earth will carry you into the edge of a stream while you are unconscious, and the light will happen above your roof, and you will not see any of it, and it will happen anyway. That is allowed. That has always been allowed. Nothing about this requires your attendance. Let me take you out there now, not as a lesson, just as a place to rest for a while. Let the facts we have gathered become scenery, and let yourself be somewhere. Imagine that you are one of the grains. You are perhaps a millimeter across, a loose aggregate of dust and dark grains, more air than substance, held together by almost nothing. You began somewhere on the surface of a comet, packed into ice that had not melted since before the planets finished forming. You spent an unimaginable stretch of time in that condition, and nothing happened, and nothing needed to. Then, slowly, warmth, the comet is coming inward. The ice around you begins to turn to vapor, and the vapor lifts, and you lift with it, and you leave the surface at the speed of someone walking across a room. There is no wrench to it. There is no violence. You simply stop being attached and drift, and the comet falls away beneath you at the pace of a slow tide going out. And then, nothing again, for a very long time. You are in orbit now on your own account. Your path is almost exactly the path of the comet you came from, tilted by a fraction of a degree, longer by a fraction of a percent. You are heading outward. The sun behind you shrinks and cools. You pass the distance of Mars, of Jupiter, of Saturn, and with every million kilometers you travel more slowly, gravity easing its pull, until out at the far end of your enormous ellipse, you are barely moving at all, drifting through a dark so complete that the sun is only the brightest of the stars. You are not cold, because you are not anything that can be cold. You are not waiting, because waiting requires expectation. You are a fragment of an old body on a curve, and the curve does the rest. Then, imperceptibly, you begin to fall back in. Decades, sometimes centuries. The sun grows from a star into a lamp, and you gather speed as you come, faster and faster the closer you get, and around you, spread across a volume you could never perceive, are the millions upon millions of grains that left when you did, and in the centuries before and since, all of them on nearly the same path, all of them arriving at nearly the same time, all of them entirely unaware of each other. You are not in a crowd. The distances between you and your nearest neighbor in the stream might be hundreds of kilometers. It only looks dense from outside, and only when a whole planet is sweeping through. Now imagine, instead of being the grain, that you are drifting alongside it. You are out on the road, not falling, not fearing, just held in place beside this one particle of an old comet, matching its motion so precisely that it appears motionless beside you, hanging there, no larger than a poppy seed. The sun is far off and small. There is no wind, no sound, no pressure, no direction that means up. Your body has no weight and nothing to press against. The stars do not move. They will not move for centuries. There is nothing whatsoever that needs doing here. And then, from somewhere behind and to the side, a blue point of light comes into view, and it grows, and it becomes a disk, and the disk becomes a world. The Earth arrives. It does not slow down and it does not aim. It simply crosses, all of it, the whole planet, 12,500 kilometers of it, sweeping through this stretch of road at 30 kilometers a second, its atmosphere leading, that thin blue rim of air at the edge, and it takes about 7 minutes for the entire planet to pass through the place where you are drifting. 7 minutes. That is how long the Earth takes to cross its own diameter. The whole world, oceans and mountains and cities, and every person who has ever lived, and every person listening tonight, sliding past you in the time it takes to make tea. And somewhere on the night side of that passing world, on the leading face, at some address under a dark sky, someone is lying on their back on a blanket, cold, patient, looking up, and the grain that was hanging beside you a moment ago is gone, drawn into the blue rim, and 100 kilometers above that person's face it becomes, for 2/3 of a second, a line of light. They say something. Perhaps only a sound. Perhaps they reach out and touch the arm of whoever is lying next to them. Too late, because it has already finished. And you, out on the road, see none of that. From where you are drifting, the planet passes and is gone, and the stream continues, thinner by an unmeasurable amount, and the light that meant so much down there was invisible from here. Come back now. Come back down through the air, through the meteor layer at 100 kilometers, down through the ozone, down through the high cold, down through the clouds, down through the ordinary air of the ordinary night, down to the roof, down through the roof, down to the room you are in, down to the surface you are lying on. Feel the weight come back. Feel the mattress take it. Notice how much of your body is being held right now, without any effort from you, at every point of contact, the whole length of you supported. Your heels, the backs of your legs, your hips, your shoulders, the back of your head. You are on the outside of a sphere that is moving at 30 kilometers a second, and you are lying down on it, and it is holding you, and it will keep holding you all night without being asked. That is the same arrangement as the appointment. Something enormous is doing all the work, has been doing it since long before you arrived, will keep doing it after, and asks nothing of you except that you continue to exist on top of it. You do not have to steer. You do not have to keep track. You do not have to remember to be carried. Let your breath go out longer than it comes in, once or twice, not as an instruction, just as a thing you might drift toward. And let the whole enormous machinery of orbits and streams and crossings run on, without your supervision, exactly as it has been doing this entire time. I want to talk now about how much of it there actually is, because the numbers here are the opposite of what almost everyone expects, and because there is a particular kind of comfort in them. Picture the display again. 100 meteors an hour on a good Perseid night, over a whole hemisphere of sky, sustained for several nights running. It feels like a great deal of material. It looks, from underneath, like the sky is losing something. Add it up. The total mass of all the meteoroids the Earth sweeps up during the entire peak of a major shower, everything that produces a visible streak anywhere over the whole planet across the whole night, comes to something in the region of a few tonnins. A few tonnins. That is the load of a delivery lorry. That is less than the weight of a single adult elephant, spread across the entire surface of a world, arriving in fragments smaller than raindrops over the course of a night. At 70 kilometers a second. The entire visible spectacle of a meteor storm, the one that made people in 1833 believe the world was ending, involved a total quantity of matter you could have loaded into a couple of vans. And the stream itself, the whole enormous tube of debris looping around the sun, out past the giant planets and back, hundreds of millions of kilometers long, estimates for a well-developed stream like the Perseids run to something on the order of 100,000 tons of material, perhaps more, perhaps less. It sounds like a great deal until you consider the volume it is distributed through, at which point it becomes almost nothing at all. If you were out there in the thickest part of the Perseid stream, in a spacecraft with the best instruments we can build, you would find, on average, roughly one meteoroid of visible size in every few hundred cubic kilometers. Let that resolve. A few hundred cubic kilometers, that is a box larger than most cities, and inside it, 1 grain of sand. The stream is emptier than the emptiest place you have ever stood. It is emptier than a laboratory vacuum by an enormous margin. If you were dropped into the densest part of it, you could look in every direction and see nothing whatsoever, and drift for a very long time without encountering anything at all. There is no cloud out there. There is no swarm. There is no wall of rock that the Earth crashes into. What there is a planet 12,500 kilometers wide, moving at 30 kilometers a second, sweeping out a volume of a few 100,000 cubic kilometers every second of its passage. And when you sweep a volume that large through a density that low, you collect 100 grains an hour. That is the entire arithmetic of a meteor shower, an almost perfectly empty road, and a very large vehicle moving very fast for a very long time. The spectacle is not made by abundance. It is made by scale multiplied by patience. I find that genuinely settling, and I want to say why, because it connects to something more useful than astronomy. We are taught more or less constantly that impressive results require impressive quantities, that to make something visible you need a great deal of material, a great deal of effort, a great deal all at once. And here is a phenomenon that has been putting on one of the most affecting displays available to human beings for the entire span of recorded history, and it is doing it with a few tons of dust and one very large slow arrangement that never varies. It does not intensify. It does not try harder in November than in June. It simply keeps going, and the going is enough. There is also this. Everything we have described tonight is old. The dust in the August stream was released across the last 2,000 years or so, some of it further back. The comet that released it has been on that orbit for far longer. The material the comet is made of is older still. It is unprocessed leftover from the formation of the solar system. Ice and dust that never got incorporated into a planet, that has been sitting out in the cold, essentially unchanged, for 4.5 billion years. When you watch a meteor, you are watching something older than the ground under your house, older than the oceans in their current arrangement, older than the continents, older than life. It has been out there, unchanged, for 4.5 million years, doing nothing, waiting for nothing, and then in 1 second above your head it becomes light and heat and a scattering of atoms, and it is over. And the thing that ended it was you. Not you personally, but the planet you are riding, arriving on schedule, as it has arrived every year for as far back as anyone can check. Here is the comfort I actually want to leave you with from all this, and then I will let the numbers go. Nothing about this system is fragile. You do not have to worry about the streams running out, They are replenished every time the parent comes around, and the dispersal that thins them takes tens of thousands of years. You do not have to worry about the material harming anything. It is dust, and it is stopped by air 100 kilometers up every single time without exception, and it has been doing so for the entire history of the planet. You do not have to worry about missing one. There is another in a few weeks, and another after that, and the calendar does not close. There is no version of this where you have failed to keep up. There is no deadline in it anywhere. The appointment that keeps itself has no attendance record, no consequence for absence, and no capacity to be disappointed in you. If you fall asleep before the end of this, you have not missed anything. The stream will be there. The date will come around. And the next time you happen to be outside at the right hour, under a sky dark enough, with your head tipped back and your eyes adjusting, one will cross, and you will not have had to do anything at all to deserve it. Since we have come this far, let me tell you how you would actually watch one, if you ever wanted to. Not as homework. Consider it a description of a pleasant evening you might have at some point, offered mainly so that you can picture it happening. The first thing to know is that you need no equipment whatsoever. This is the only branch of astronomy that is actively harmed by instruments. A telescope shows you a patch of sky a fraction of a degree across, and a meteor could cross a quarter of the heavens. The odds of one wandering through that keyhole while you happen to be looking are effectively nil. Binoculars are no better. The correct instrument is your own eyes, unaided, taking in the widest possible view, and the correct mounting for that instrument is your back, on the ground, with something under your head. The second thing is darkness, and darkness takes time. Your eyes have two adaptation systems. The pupil opens within seconds, which is the part people notice. But underneath that, the light-sensitive chemistry of your retina is rebuilding itself, and that process is unhurried. It takes about 20 minutes to get most of the way there, and closer to 40 to be fully adapted. And by the end of it, you can be 1,000 times more sensitive to faint light than you were when you stepped out of a lit room. The consequence is that the sky gets better the longer you stay, and it gets better in a way that feels like the sky is changing rather than you. Stars appear that were not there before. The gaps fill in. On a properly dark night, somewhere around the half-hour mark, the band of the Milky Way separates itself out of the background and becomes a visible structure, and people who have never seen it sometimes mistake it for a cloud. And a single glance at a phone screen undoes almost all of it. In an instant, and you have to start the 20 minutes again, which is why the deepest pleasure of a meteor watch is not the meteors, it is the enforced disconnection. It is the only recreational activity I know of where looking at your phone is not merely rude, but physically self-defeating. The third thing is the position of your body, and here the advice is entirely practical and entirely about comfort. Lie down. Do not stand. Do not crane your neck. A neck held at an angle for an hour will end the session long before your patience does. A reclining chair, a blanket on the ground, a sleeping bag in a garden. Something over you, because you will get colder than you expect, you are motionless and radiating heat directly up into a clear sky, and clear skies are what make you cold. Something warm to drink, held in both hands. The fourth thing is where to look, and the answer surprises people. Not at the radiant. Meteors near the radiant are foreshortened, coming almost straight at you, and they appear as brief points rather than streaks. The long, spectacular ones, the ones that draw a line across a third of the sky and leave a train hanging behind them, appear well away from the radiant, 30 to 60 degrees off. So the practical advice is to face in the general direction of the radiant, but look higher, up toward the top of the sky, and then to let your gaze go loose and unfocused, and take in as much as possible at once. Your peripheral vision, as it happens, is better at detecting motion and faint light than the center of your field of view. Most meteors are caught out of the corner of the eye. You will see a flick at the edge of your attention and turn, and it will already be gone, and you will have to decide whether to count it. That is the ordinary texture of a meteor watch. Half of it is things you almost saw. And the fifth thing is patience and honesty about the numbers. You will read that a shower produces 100 meteors an hour. That figure is a technical quantity called the zenithal hourly rate, and it describes what a single observer would see under a perfectly dark sky, with the radiant directly overhead, with unobstructed vision in every direction. Nobody has ever observed under those conditions. The radiant is rarely overhead. There are trees, buildings, a horizon. There may be a moon. There is almost certainly some light pollution, and light pollution is brutal to meteor watching because it wipes out the faint ones, and the faint ones are the majority. So the real number, for a real person in a real place, is more often 15 or 20 an hour than 100. 1 every 3 or 4 minutes, long stretches with nothing, and then 2 in 10 seconds, because they cluster the way random things cluster, in a manner that always feels like it means something and never does. Which means the correct expectation, the one that will not disappoint you, is this. You are going outside to lie in the dark for an hour, and the sky is beautiful, and occasionally something will happen. And that framing, I think, is why meteor watching stays with people the way it does. It is one of the last activities with no way to make it more efficient. You cannot speed it up. You cannot pay for a better rate. You cannot optimize the waiting away. The only strategy is to be present, on your back, for longer, and the rewards arrive on their own schedule and cannot be summoned. There is nothing else quite like it left. Almost everything we do now has a way to skip ahead. This one does not. And the moment itself, when it comes, is so short that it barely qualifies as an event. A line of light appears. It brightens. It fades. The whole thing takes less than a second, often much less. It is over before you have turned your head. You cannot show it to anyone. You cannot rewind it, and the person lying next to you may have missed it entirely. Which means that every meteor anyone has ever seen was seen by whoever happened to be looking in that direction at that moment, and by nobody else in quite that way, and then it was gone. It is the least shareable, beautiful thing there is, and there is something in that worth holding, an experience that cannot be captured, cannot be repeated, and does not need to be, because another one is coming. But let us take the question literally now, because we have earned it, and because there is a version of it that deserves a straight answer with real numbers attached. Suppose you refused the poetic answer. Suppose you said, "No, I do not want to be carried. I want to go. I want to build something, climb into it, leave this planet behind, and travel out to the stream under my own power, and be among the dust rather than under it." How long would that take? The answer depends entirely on how far out you want to go, and that is a more interesting question than it sounds, because the stream is not one distance away. It is a loop. Parts of it are right here, crossing our own orbit, and parts of it are out beyond the giant planets. If you only want to reach the nearest part of the stream, the part the Earth crosses, then the honest answer is that you are already inside it once a year, and would only need to get above the atmosphere to be properly among it. 100 kilometers up, straight out of the meteor layer, and you would be in the same volume of space the grains occupy just before they arrive. That is a 9-minute rocket ride. That is genuinely all it takes. People have done it. They have done it without noticing they were doing it, because as we established, the stream is so thin that you could sit in the middle of it and see absolutely nothing. That is the first strange consequence of taking the question literally. If you fly to a meteor shower, there is nothing to see when you get there. The shower does not exist out in space. The shower is an atmospheric event. The light happens only where the dust meets the air. Go out to the stream and you find empty vacuum with one poppy seed every few hundred cubic kilometers. The spectacle is not at the source. The spectacle only exists at the meeting point, and the meeting point is here, above your roof, which is precisely where you already are. But suppose you want more than that. Suppose you want to go to the far end of the road, out to where the parent comet spends most of its long life. Comet Swift-Tuttle, the source of the August meteors, goes out to about 50 times the Earth's distance from the Sun at the far end of its orbit. That is roughly 7.5 billion kilometers. Our fastest departures from Earth, the probes we have flung out toward the outer solar system with every gravitational assist we can arrange, manage something around 15 to 20 kilometers a second once they are clear of the Sun's grip. At that speed, 7.5 billion kilometers takes something like 12 to 15 years, which is a long time and also, notice, not an unimaginable time. It is within a career. It is less than a childhood. We have already done journeys of that order. The probe that reached Pluto took 9.5 years and is still traveling outward now. The two Voyagers have been going for close to half a century and are beyond the influence of the solar wind entirely. Reaching the far end of the Perseid Road is a journey of the same family as journeys we have actually made. And when you got there, you would find, again, essentially nothing. Cold, dark, a sun no brighter than a very bright star, and dust so sparse you would need instruments to confirm it was there at all. You would have traveled for 15 years to arrive at a place indistinguishable from anywhere else. Now let me put the last comparison in, because it is the one that closes the argument. The Earth, doing nothing, making no effort, following the same path it has followed for 4.5 billion years, delivers you into a meteoroid stream 9 or 10 times a year, at no cost, requiring no preparation, and delivers you to the one place in the entire arrangement where the dust becomes visible. There is no engineering project that improves on this. There is no vehicle that would give you a better view than the one you get from a blanket in a field. Every spacecraft we have ever built, every trajectory we have ever computed, would take you further from the phenomenon rather than closer to it. The best seat in the solar system for watching a meteor shower is the surface of the Earth, at night, on the leading face, with your eyes adapted. You already have that seat. You have had it your whole life. It came with being born here, so the literal answer to the literal question turns out to fold back into the poetic one, which does not usually happen and is very satisfying when it does. How long would it take you to reach a meteor shower? 0. You cannot reach it, because you cannot leave it. You are in the audience by default, and there is no way to buy a better ticket. And the only real variable, the only thing that determines whether you see one, is whether you happen to be awake and outdoors and facing upward on one of the 9 or 10 nights a year when the crossing is thick enough to notice, which is a matter of chance and weather and the ordinary shape of a life. Some years you will catch one, some years you will mean to and forget, and read about it afterward, and feel a small, flat disappointment that fades within the hour. Some years it will be cloudy in your particular part of the world, while 300 kilometers away the sky is clear, and there is nothing to be done about that either. None of it changes the appointment. It was kept. You were carried through it whether you looked or not, whether the sky was clear or not, whether you were asleep or awake. The dust arrived above the clouds at 100 kilometers and turned into light in a layer you have never visited, and no eye anywhere had to witness it for it to have happened. There is a kind of relief in things that do not require witnesses. I want to spend a little while on scale before we begin to close, because scale is the thing that most often makes people feel small in an unpleasant way, and I think that reaction is a misreading, and I would like to offer a different one. The usual framing goes like this: the universe is enormous, and you are tiny, and your concerns are therefore insignificant. And this is supposed to be either humbling or crushing, depending on the day. It gets delivered in a particular voice, usually over swelling music, and it always ends with the word dust. I would like to take the word dust back, because we have spent 2 hours with dust tonight, and it has been nothing but generous. Here is what the scale of this actually shows. When you look at the details, rather than the headline. A grain of cometary material, smaller than a seed, 4.5 billion years old, arrives in our air and produces a flash of light that 100,000 people can see at once across 3 countries. It is one of the smallest objects it is possible to notice, and it produces one of the largest visible effects available in nature. Smallness in this system is not the same as insignificance. Smallness is what makes the light possible. A larger object would not vaporize so completely, would not spread its energy so beautifully, would come down instead of flaring. And consider what has to line up for you to see one. An object had to form in the outer solar system before the Earth finished assembling. It had to survive 4.5 billion years without being swept up by a planet or thrown out of the system. It had to be captured onto an orbit that brings it inward. It had to be heated enough to release you, this particular grain, at this particular time. The grain had to drift for centuries into exactly the part of the stream the Earth crosses. The Earth had to arrive on schedule. Your part of the planet had to have rotated into night. The sky above your particular roof had to be clear. And you had to be outside, awake, with your eyes adapted, facing roughly the correct direction at a specific second. All of that for 2/3 of a second of light. That is not a story about insignificance. That is a story about how much has to hold together for a small thing to be witnessed, and about the fact that it does hold together 9 or 10 times a year, reliably, without anyone maintaining it. There is also the ordinary, physical intimacy of it, which I keep coming back to because it is easy to state and hard to absorb. The material of comets did not only make meteors, it made a good deal of what you are. The water in your body came from somewhere, and a meaningful portion of the water on this planet arrived in the form of ice delivered from the outer solar system during the long chaotic period when the planets were settling into their positions. The carbon in you was made in stars and delivered here in dust. You are, in a completely literal and unmetaphorical sense, made of the same category of material that is burning up above your roof tonight, and the difference between you and it is mostly a matter of which arrangement each parcel happened to fall into. So when you look up at a meteor shower, you are not a small separate thing looking at a large separate thing. You are one arrangement of ancient material watching another arrangement of ancient material arrive. The distance between you and it is 100 kilometers and about 4.5 billion years, and neither of those is as much of a gap as it sounds. And the appointment. One last turn of it before we start to let go. The thing I love most about the appointment that keeps itself is that it predates the concept of appointments. It was not made. Nobody arranged it. It emerged from two orbits happening to intersect, and it has been kept, on time, every year, for longer than there have been eyes to notice. It was kept during every century of human history, through every war, through every ordinary Tuesday, through every night that anyone has lain awake worrying about something that turned out fine, and every night that anyone lay awake worrying about something that did not. It was kept in the years before you were born. It will be kept in the years after. That is not a reminder of how little you matter. That is a demonstration that something is holding steady underneath everything, at a level nothing you do can disturb, and nothing that happens to you can interrupt. And you are inside it, not observing it from outside, riding it. Carried at 30 kilometers a second toward the next crossing, while you lie completely motionless in a warm bed, doing nothing whatsoever, which is exactly the correct amount to be doing at this hour. There is a particular kind of tiredness that comes from feeling responsible for keeping things going. Most people carry some version of it. The sense that if you stop attending, stop tracking, stop holding it all in mind, something will slip. I do not know what your version of that is, and it is not my business to guess. But I can tell you that the largest and most reliable system you are personally involved in requires absolutely nothing from you. The Earth will complete tonight's portion of its orbit without your input. It will carry you 900,000 kilometers further along the road between now and this time tomorrow. It will bring you to the next stream on schedule. And it will do all of that while you are unconscious, which is the state it would rather you were in if it had preferences, which it does not. You can put it down, whatever you are still holding at this hour, whatever list is running in the back of your mind, you can set it on the floor beside the bed, and it will be there in the morning if you want it. And a great deal of it will look smaller in daylight, and some of it will have quietly resolved itself, and none of it needs solving between now and dawn. The dust is arriving. It has been arriving the whole time we have been talking. 40 to 100 tons a day, mostly invisible, mostly too small to see, settling down through the air over the course of weeks to become part of the ordinary surface of the world. It is arriving over the ocean, and over the mountains, and over every roof in every city, including yours. It does not stop when you sleep. It does not need you awake to keep coming. There is one more thing I want to give you before we begin to let the night go, and it is the smallest fact of the evening, and I have been saving it. Every meteor that has ever been seen was seen only once. Not once by that person. Once, full stop, in the entire history of the universe. The grain existed for 4.5 billion years, and then it did not exist. And the 2/3 of a second in between is the whole of its visible life, and whoever happened to be looking in that direction at that moment is the complete and final audience. There is no recording of most of them. There is no second showing. The atoms are dispersed into the upper air within seconds and will never be assembled into that particular object again. which means that every person who has ever pointed and said, "Did you see that?" was reporting something genuinely unrepeatable. Not rare, unrepeatable, and the person beside them either caught it or did not, and if they did not, there was no way to show them. And both of them knew it, and that is why the pointing is always a little urgent and always a little too late. For as long as there have been people, this has been happening. Someone on a hillside 3,000 years ago, minding animals through a cold night, saw a line of light and had no framework for it, and felt something anyway. Someone on a ship, on watch, alone, in the middle of an ocean, in a century with no electric light anywhere on the horizon. Someone leaning out of a window in a city during a power cut. Someone driving on an empty road at 4 a.m. who saw it through the windscreen and had nobody in the passenger seat to tell. All of them looking at the same layer 80 to 120 kilometers up. All of them looking at material from the same handful of streams. All of them, without knowing it, being carried through the same appointment on the same vehicle, separated only by the ordinary distance of years. You are in that line. Whether or not you have ever seen one, you belong to the sequence of people who have been carried through these crossings, and the sequence has no gaps in it. There has not been a single year in the whole span of human presence on this planet when the August dust did not arrive. Not one. Through every century you can name, in every condition people have lived under, the road was crossed and the light was made above the clouds, whether the sky below was clear or thick, whether anyone was outdoors or everyone was indoors, whether the world at that moment was going well or going badly. It went on. It is the one thing that has never once been interrupted. And it is going on now, above the roof, above the cloud layer, if there is one, in a band of air so thin it barely counts as air, where a grain older than the ground is coming to the end of an extremely long journey and turning into light that nobody at all may see. That is happening right now, as you lie here, not on a shower night especially. Every night, several times an hour on any night of the year, from the ordinary background of material the solar system leaves lying around. The sky is never entirely empty of arrivals. You could go and look if you wanted. You are not going to, and you should not, because it is late and you are warm, and the whole point of tonight is that you do not have to go anywhere. But it would be there. That is the part worth carrying into sleep. It would be there if you went, and it is there while you do not, and the difference between those two states matters only to you and not at all to the sky. So let us begin to let all of it go now, slowly, the way you let go of a day. Tonight has been about a question that turned out to be shaped differently than it looked. Tonight has been about a road rather than a destination, about a date rather than a place, about being carried rather than traveling. Tonight has been about an appointment that keeps itself, made by nobody, kept by everybody, requiring nothing. Tonight has been about comets warming as they come inward, losing their ice to vapor, releasing grains at the pace of someone walking across a room. And about those grains drifting along the same enormous loop for centuries afterward, out past the giant planets and back, in a cold and a dark and an emptiness, with nothing in it at all. Tonight has been about a stream so thin that you could sit inside it and see nothing, and about a planet large enough and fast enough that sweeping through such emptiness for a few hours produces 100 lines of light. Tonight has been about the radiant, which is not a source but a vanishing point, not a place but a direction. The perspective trick of parallel paths converging. The same illusion as snow on a windscreen and the two edges of a straight road meeting at the horizon. Tonight has been about speed. 11 kilometers a second at the least, because gravity permits nothing more leisurely. 71 for the November meteors, arriving head-on against the direction of the planets. 59 for the August ones, angled and bright and generous. 35 for the December ones, unhurried enough to hold their color, made of stone rather than snow. Tonight has been about the fact that the light is not burning and is not friction, but air compressed so violently that it has no time to move aside, and atoms stripped from a surface and knocked into brightness and falling back to rest. Tonight has been about a grain of sand producing a flash seen across 100 kilometers of countryside, about the largeness of the effect and the smallness of the cause, about a few tons of material, no more than a delivery lorry could carry, producing the display that made an entire continent believe, on one November night in 1833, that the world had come to its end. Tonight has been about that night, and about the frightened people who came out into the roads in their night clothes, and about the ones among them who kept notes, and about how the radiant moved with the stars instead of with the ground, and how that single observation lifted meteors out of the weather and put them into space where they belonged. Tonight has been about 33 years, and about a prediction that came true in 1866, and about two orbits laid side by side that matched too well to be coincidence. Tonight has been about Swift Tuttle, 26 kilometers across, out beyond Pluto's distance now, due back in 2126. About Temple Tuttle on its tight retrograde loop, refreshing the November ribbons every third decade. About Phaethon, heated to 700 degrees, cracking rather than melting, shedding stone. Tonight has been about a thin shelf of air, 80 to 120 kilometers up, closer than most cities you have driven to, an hour away at motorway speed if roads went upward. The nearest astronomy there is, the one part of the sky that comes down to meet you. Tonight has been about lying on your back in the dark for an hour, with no instrument and no way to hurry it, and about how the sky improves the longer you stay because your eyes are still rebuilding themselves. Tonight has been about the dates: early January, late April, early May, late July, mid-August, late October, through November, mid-December, and again just before the year turns. 9 or 10 crossings a year, never more than a few weeks from the next one. Measured in nights of sleep, not in distance. You do not have to hold any of it. You do not have to hold any of it. You do not have to hold any of it. The comet does not need you to remember its name. The stream does not need you to remember its dates. The Earth does not need you to remember that it is moving. It keeps its own appointment. It has kept it for 4.5 billion years. It will keep it tonight, and the night after, and every night after that, entirely without your supervision. None of this needs anything from you tonight, not your attention, not your memory, not your understanding. You are allowed to have drifted out somewhere around the comets and never come back. You are allowed to have missed most of this. You are allowed to have followed none of it at all. Nothing has been lost, because nothing was being kept. If any of this was good company at this hour, there is a like and a subscribe, and they help these reach other people lying awake in other rooms. That is all. No urgency in it, and no need to move. When this ends, another one will begin on its own, a little further along, and you will not have to touch anything or choose anything. It will simply continue, the way the road continues. And if you find yourself awake and thinking, here is something to leave in the comments whenever you next surface, tomorrow, or next week, or never. Have you ever seen one? Just one, unexpectedly, out of the corner of your eye. Where were you? And who were you with? And did they see it too? I read them. Other people read them at 3 a.m. and find they are not the only ones awake, but not now. Now there is nothing to do. Let your attention come down out of the sky, down out of the far orbits and the cold, down through the layer where the light is made, 100 kilometers up, down through the ozone, down through the high thin cold, down through the clouds, down through the ordinary air above your street, down to the roof, down through the roof and into this room, down to the bed, down to the surface holding you. Notice how much of you is being held. The backs of your heels, the backs of your legs, your hips taking the weight and giving it away, your lower back wherever it meets the mattress, your shoulders letting themselves widen a little further apart, the back of your head resting into the pillow, heavier than a moment ago. Let your jaw come unhooked. Let your tongue rest away from the roof of your mouth. Let the small muscles around your eyes stop working, the ones that have been holding an expression all day without being asked to. Let your hands be exactly where they have fallen. There is nothing in them. Let the next breath out take longer than it took to come in, and the one after that. Not as an effort, just letting it find its own lower level, the way water does. You are lying on the outside of a sphere 12,500 kilometers across, and it is turning, and it is carrying you eastward into the small hours, and it is carrying you along an enormous curve at 30 kilometers a second, and you will be 900,000 kilometers further along that curve by this time tomorrow. You do not have to steer. You do not have to keep track. You do not have to stay awake for any part of it. Somewhere out ahead of you, on a stretch of road you cannot see, there is dust that left a comet before anyone alive was born, drifting on its own long loop, arriving where you will be. It will be there. You will be brought to it. Nothing further is required of you tonight. Sleep well.